So my name is Yuki Tani, applications engineer for scanning electron microscope. So today I would like to introduce our new Schottky FE-SEM SU3900SE. So first, I would like to speak to you about the overview of the product, and then I will explain the operation support functions and automation capabilities. So we developed two models to meet a wide variety of analytical requirements. We have developed the new Schottky optics, which have improved resolution compared to previous model. And for this product line, we have standard chamber model, SU38, and large chamber model, SU3900. For the large chamber model, SU3900, we can accommodate samples up to 300 millimeter and 130 millimeter in height. Next, we have enhanced operation support functions, both fully integrated camera navigation system and chamber scope are available. And we also have enhanced auto alignment functions. This is a new feature for us. So these features allow users, whether beginners or experts, to maximize tool performance. So lastly, we have enhanced automation capability. Recipe creator to automate the analysis workflow. We also provided dedicated holder to automate various applications. So let me explain each feature in more detail. So first, let's talk about the hardware design. The newly developed Schottky optics brings us various capabilities. These capabilities include resolution and probe current. When compared to previous model, the imaging resolution has improved. So shown on the table here, at 1 kb, the resolution has improved by 0.5 nanometer. So it also provides the probe currents up to 150 nanoampere to support various analysis. And as I told you, for SU3900SE, large chamber model, which can accommodate large and heavy sample. This is this tool's unique capability. It can accommodate samples with a diameter of 300 millimeter and a height of 130 millimeter. So it means large sample like this can be analyzed without cutting. It can also operate 5 kilogram, 11 pounds on the 5-axis stage. Yeah, this is not 5 kb, but. So this axis includes X, Y, Z, and rotation and tilting as well. So next, let me explain about the detectors. 4 imaging detectors are available to support various requirements. These include SE detector for surface topography imaging, backscatter detector at the bottom of the column for topography imaging and crystal contrast. And top detector, this is for top surface imaging in deceleration mode. This image obtained at 0.2 kb. This is very low accelerating voltage. And we also have UVD detector, ultra variable pressure detector. This is for the SE imaging in low vacuum mode. This detector can switch between both SE imaging and CL imaging mode. This is also our unique capability. Of course, we can mix 2 detector signals and we can capture 2 images simultaneously. So moving on, let's talk about the operation support function. So as you all know, obtaining high quality image requires various adjustments, such as beam alignment, aperture alignment, focus and stigma alignments. So when adjusting manually, there are a lot of challenges to obtain high quality data. So these challenges could like operational skills, such as training and support from specialists. So they look like low repeatability, like inconsistent image quality, or these repeated process adjustments can be time consuming. So to solve these challenges, we developed an old alignment sequence feature. Each alignment and adjustment can be registered and executes all steps with one click. So I would like to show you an example in a video. So you can obtain high quality images with 4-click. So this is first click, execute autofocus and stigma, and then execute auto alignment sequence. This is a new function. And this is beam alignment, aperture alignment, and next is stigma alignment. And then finally execute autofocus, stigma, increase the magnification to 50,000, and execute autofocus again. And we click capture. So with 4 clicks, you can easily visualize small particles around 100 nanometer. So this feature is also effective when we change the SEM settings. So let me show you a video of the accelerating voltage setting from 5 kV to 1.5 kV. So first, click Start button. And accelerating voltage is 5 kV and execute auto alignment sequence, beam alignment, aperture alignment, stigma alignment, and then focus and stigma. And next, we change the accelerating voltage to 1.5 kV and then perform auto alignment sequence. And increase the magnification to 20,000. Execute autofocus, and then capture. So with just only mouse clicks, you can perform surface imaging at low accelerating voltage. So no manual adjustment required, even when changing SEM settings. So, and both SU3800SE models have a camera navigation system called SEM app. This is fully integrated into our GUI, and optical camera is attached to the SEM chamber, which capture optical images during sample exchange process. Using those images, we can navigate the stage. So large chamber model allows observation of 203 millimeter. So you won't lose the location even with the large sample. The chamber scope is also available, and fully integrated into our GUI. The camera is attached to the back side of the chamber. And as you can see here, chamber scope image can be zoom in and zoom out in live mode. So this allows safe stage operations. So finally, let me explain the automation capabilities. We have developed the EM Flow Creator to automate analysis workflow. EM Flow Creator improves productivity by designing automated workflow recipes. So this means no programming skill required. You can create recipes by simply drag and drop SEM setting commands such as accelerating voltage, stage location, and magnification into the flowchart. So also, EM Flow Creator can be customized according to your needs by importing the Python-based script. So let me show you an example using EM Flow Creator. The sample is a cross-section of the printed circuit board. To check the bonding structure, interface, void, and crack, we automated the stage movement and magnification changes. The unique point of this recipe is the use of template matching. With template matching, we can register the unique structure as template images and automatically move to the similar structure. So I will show you a video. So this is a recipe to run 14 locations automatically. So first, imaging at first location, and then execute template matching and adjust the stage position and capture. After capturing, template matching will be performed automatically, and then adjust the stage again, execute autofocus, and then capture. This is the last image. And then move to the next location, next sample, and repeats the same process until the recipe is completed. So using this recipe, you can leave the lab room during your observation. And you can create your own recipe like this without any scripting. And captured images are saved to any specified folders. So finally, we provide various optional sample holders to use automation recipe efficiently. These holders can accommodate multiple samples. They are registered in our GUI, so you can use them safely, avoiding hitting the chamber and detectors. So one type of holder suitable is the filter holder. In the automotive and battery industry, filter analysis is performed to inspect the contamination analysis. So this application requires many samples, and this holder can accommodate 11 filters. Combined with EDS automation software, all 11 filters can be analyzed automatically. So after analysis, you can check the details of each particle from the data table. And this is a report templates from the EDS software as they clean, you can easily output the statistic data. The productivity of sample observation can be improved by the combination of large chamber and automation capability. So this is the end of my presentation. So thank you for your attention.